coke ovens and coal chemicals is a major department in an integrated steel plant. It supplies coke to the blast furnace and fuel gas to the entire plant. Coke provides reducing atmosphere, source of heat, semi-permeable burden and strength to the bed in the blast furnace. In the coke ovens and coal chemicals department, averaging and blending of coking coal from different sources are done. It is further sized and screened for high temperature carbonization of coal in absence of air to remove most of the volatile matter present in the coal to form metallurgical coke. The coke produced from the battery is further sized and screened to make 20 to 80 millimeter of blast furnace grade coke. The quality of coke produced is also controlled and monitored for coke ash, moisture content and strength. In the process, the raw coke oven gas obtained from the volatile matter is further processed in the coal chemicals to remove the byproducts in the form of different coal chemicals. The clean coke oven gas thus produced is used as a fuel all over the plant in areas like coke oven batteries itself, blast furnaces, reheating furnaces of mills, power plants, among others. Undersized coke generated in the coke sorting plant is sent to the raw materials handling plant for preparing blendings. In the coal handling plant, coal from different sources is received through wagons. The wagons are tippled at 3 number tipplers and the coal so tippled is sent to either silos or bed as per the requirement. There are 15 new silos and 14 old silos. The capacity of each old silo is 1400 tons and it is 2500 tons for each new silo. Each silo is earmarked for keeping coal from a particular source. The coal blending or proportioning is done by drawing coal from different silos through wave feeders. There are 10 numbers of operational coal beds for stacking coking coal for coke ovens, middling coal for power plant and CDI coal for coal dust injection at blast furnaces. Coal is sent from tippler and stacked through 6 numbers of wing tippers. The coal from the bed is reclaimed through 6 numbers reclaimers and is sent to the silos. Coal from the silos blended at the wave feeders is sent to the crushers. There are 4 numbers of crushers. The crushing is done in such a manner so as to ensure a maximum of 82% coal feed being of size less than 3.12 millimeter. The total coal feed is sent to the battery coal bunker through conveyor belts. There are 4 numbers of coal bunkers or coal towers, namely 1, 2, 3 and 4, which can cater to 6 numbers of coke oven batteries. The capacity of each coal bunker is 4,000 tons. During monsoon, additive like high-speed diesel is added to improve the flowability of coal feed to the bunker. Now let's look at the battery. A coke oven battery is made of silica, fire clay and insulation refractory bricks, and they are kept in position with the help of mechanical anchorage system. Normally, 4 to 5 batteries are kept in operation and 1 battery is kept in reserve for repair and rebuilding. In DSP, all the batteries are of top charge recovery type, that is, coal is charged from the top and the raw coke oven gas is collected from the top. The heat for high temperature carbonization of coal in the battery is provided by using under firing system. Here, either coke oven gas or blast furnace gas is used for heating. The fugitive emissions in coke oven batteries are maintained as per the norms set by the Central Pollution Control Board. Each battery is having a pair of pusher car, charging car, guide car and an electric loco-driven hot coke quenching car. In the battery, coal is taken from the coal bunker and is loaded in the charging car. Coal is charged in ovens from the charging car and the leveling is done through the pusher car. The useful volume of each oven is 23.8 cubic meter, which produces around 10.5 tons of coal. The coal remains in the oven for 19 to 20 hours at a temperature of around 1200 to 1250 degrees centigrade. After completion of the coking period, the coke is pushed out by the pusher car. The raw coke oven gas produced is cooled down from 800 degrees centigrade to 80 to 85 degrees centigrade in gas collecting main using ammoniacal liquor spray. The gas is then sent to the coal chemicals for further processing. For pushing, the pusher side door is opened by the pusher car. The guide side door is opened by the guide car and the guide car cage is placed. After proper placement of the quenching car, the pushing is carried out. The hot coke pushed out from the ovens at a temperature of 1000 to 1050 degrees centigrade is collected in the quenching car, which is taken to the quenching tower for cooling by water spray. After this, the quenched coke is dumped in the wharf. The coke in the wharf is then sent to the coke handling plant through conveyor system. In the coke handling plant, the coke is passed through 80 mm grizzly. The oversized coke, that is coke with size more than 80 mm, is sent to the coke cutter. The undersized coke, that is coke with less than 80 mm size, and the coke after the cutter are sent to 20 mm grizzly. From the 20 mm grizzly, the coke with size more than 20 mm is sent to the blast furnace. The undersized coke is collected in the domestic bunkers for subsequent use in raw materials handling plant and sinter plant. Coming to the coal chemicals, The byproducts in the raw coke oven gas are separated in this plant sequentially, and thereafter the clean coke oven gas is distributed throughout the plant as fuel. The coal chemical section consists of gas condensation unit, ammonium sulfate plant, final gas cooler cum naphthalene scrubber, benzol plant, tar plant, and biological oxygen demand or BOD plant. In the gas condensation unit, the raw coke oven gas is taken to downcomer for the separation of ammoniacal liquor, tar and gas. Tar and liquor, being heavier, goes from downcomer to decanter where liquor is separated from tar. The gas, being lighter, goes up from downcomer and it is then cooled from 80 to 85 degrees centigrade to 30 to 35 degrees centigrade in primary gas coolers. After this, the gas, which is being sucked by exhausters, is sent to the downstream. After cooling and removal of tar and liquor, the coke oven gas is sent to the ammonium sulfate plant. In the ammonium sulfate plant, the gas is fed in the absorber from the bottom and diluted sulfuric acid of concentration 1.5% is sprayed from the top. This leads to formation of ammonium sulfate. The ammonium sulfate, which is collected at the bottom of the absorber, is crystallized in evaporator and is marketed as Raja fertilizer. DSP's branded fertilizer is very popular in the agricultural market. The coke oven gas from the absorber is passed through the final gas cooler cum naphthalene scrubber. In the scrubber, wash oil at 38 degrees centigrade temperature is poured from the top while the gas is introduced from the bottom. In this process, rich naphthalene oil is produced and is collected at the bottom. It is then sent to the stripping column where naphthalene and wash oil are separated. Then, in the final gas cooler, the temperature of coke oven gas is lowered to 20 to 22 degrees centigrade. The naphthalene-free gas is then sent to the benzol scrubber. In the benzol plant, the gas is passed through the benzol scrubber. In this scrubber, wash oil at 25 to 30 degrees centigrade temperature is poured from the top and gas is fed from the bottom. The benzolized oil so produced is collected at the bottom and is then sent to the distillation unit where benzol and wash oil are separated. Thereafter, the clean coke oven gas is distributed throughout the entire plant as a fuel. In the tar plant, the tar accumulated after gas cooling is sent to the furnace to raise its temperature to 140 to 150 degrees centigrade. The tar is then sent to the distillation column where the crude tar partial distillate or CTPD is separated. Then the remaining tar is sent to the fractionating column where the naphthalene oil and heavy creosote oil are separated. In the biological oxygen demand or BOD plant, all the phenolic effluents and waste streams of the coke ovens are processed. After the treatment, the water is once again recycled back in the process. The wastes generated at the BOD are disposed of as per norms through outfall number 5 to Damodar River. TSPs, coke ovens and coal chemicals, is in operation since 1959, is continuously infusing technological advancements, stood the test of time and is striving for excellence.